It has a lot of organic material in it. The coal burn in western New York in our power plant here in Dunkirk is mostly western U.S. coal from mines, I believe, in Montana. For the most part, it is considered low sulfur coal, which does not mean that it doesn't have any sulfur, but it is lower than the coal that you get in the Midwest and in the East. And if you've ever been out west and see these trains, these things go for miles, by the way. You'll see the ones that are going from west to east loaded with the coal. And on the other track, on the other side, you will see the ones that are empty in coal. They are constantly going back and forth. Environmental effects of coal burning. And I want to show you this because this is the stuff, when you start out with coal, this is what is going to be released when you burn it and when you're making that ash, okay? So this is what's going up, mostly going up your smokestack. Although there's some other things that are mentioned in here too about the environmental effects of just mining coal, which can be bad too. So there's release of carbon dioxide. We all know about that, contributing to global warming. I don't think too many people would argue with that. Acid rain, mostly from the sulfur dioxide that goes up. Remember the sulfides that I said was in the coal? Well, that combines with oxygen when you burn it, and that goes up the stack. That makes sulfuric acid in the atmosphere. And by the way, natural rain is always acidic because of carbon dioxide. It makes carbonic acid. And there is sulfuric acid in the atmosphere from volcanic eruptions. So there is natural amounts, but when you burn coal, you exacerbate that problem. You make the content of acid in the air larger. Also nitrous oxides, which are a component of smog and things like that, not good for your lungs. Cyanide, believe it or not, and a lot of other airborne toxics. Many of those metals that I showed you there are also going up the stack. And then when you mine it, you have drainage problems. You probably heard about the release of toxic materials in the Tennessee Valley Authority, that went down and caused a lot of damage, etc. Heavy metal contamination, not just to the air, but also in surface and groundwater. And outgassing of methane can be a problem from mines. Methane is something that definitely is produced by coal. It's produced by the Dunkirk shale too. And it is a much more potent greenhouse gas, by the way, than carbon dioxide. I put this one last down here, heavy metal contamination in the air, because it's really one of the most important things actually, and that's mercury contamination. You're going to see some analyses of mercury later on. So keep in mind that mercury and a lot of those other heavy metals are going up the smokestack, but you're going to see some of it stays behind. This is the Dunkirk steam plant. You are all familiar with that. And this is a picture that I took of one of these stacks over here. You can kind of did a little digital magic of it so you can see that even when it looks like nothing's coming out of the stacks, there really is. Most of that is probably steam. But in that steam could be a lot of those heavy metals and things like that that I mentioned before. And there's certainly carbon dioxide coming out of the stack, etc. Just to show you the extent of the pollution from power plants as measured in terms of the amount of carbon that settles over the land from their burning. Most of this is coming from the Ohio River Valley, which is famous for its coal plants. And that stuff comes right up to where we are in western New York. And if you look at the map here, the higher the concentrations, the redder it gets. And if it's orange, that's pretty high. Yellow's pretty high. The western states are not so bad. But most of the pollution is in the east. And look where western New York is here. It's actually covered by that orange. So our air is not as clean as we might like to think. Well, let's get to the bottom ash. We'll get to the bottom of this, I guess I should say, right? That's what it looks like. I don't know does it really look like that? Yeah. It's gray. It's a gray color and usually kind of a dark gray, the samples that I've seen. And so let us go on. And it's quite, mostly it's very granular, about the consistency of sand or silt or whatever. There's some clumping. This thing right here is a big clump, so some of it sticks together. So let's see if it's actually cleaner than coal. I have some chemical analyses that were done. Diane, who's going to be talking to you later, actually had this one done. And this was provided by NRG from the power plant. And if you look carefully, and this is coal, this column over here. And these are the things that were analyzed for. Mostly metals. And what you find here is that if you look at these numbers, you'll find that the coal is almost invariably higher in these numbers. It's exactly what you would expect compared to the ash. And the ash, yes, is cleaner than the coal. There's no question about it. But it's exactly what you'd expect, because when you burn coal, many of these things are going up the smokestack and they're polluting your air. But there is, as you can see here, there are numbers for all of these things. And whether they're high or low or not it depends upon the standards that you look at as to how they actually affect the environment. Let me just show you this one right here. This is kind of interesting, what I've put in blue. If you look at the amount of mercury, for instance, which is this upper line right here, 0.11, that's parts per million. That's very, very small. That's a tiny, tiny bit of mercury. And notice this is coal. So when you burn that tiny, tiny little bit of mercury, you still create a major, major problem in terms of heavy metal pollution. Now look at the ash. Both of these ashes, it's even lower, 0.02 and 0.07. Average those together, you get what, about 0.05 or something like that. But it doesn't matter. I mean, that's an extremely low number. But it's almost comparable to the coal, you see. And then you look at lead. Lead, 74 parts per million, which is still a very low number, but lead is considered one of the major pollutants from coal burning. And then if you look at it here in the ash, 5.57 and 8, those are very low too. But again, we expect that. We expect the metals to be lower in the ash. Okay. Now, if you look at again, this is a nice graphical way of looking at these. Most of these things are considered to be problematic in terms of pollution. And what you've got here is the coal is the diagonal columns here, and the ash is the crosshatched. And you'll notice again that the coal overwhelmingly has more of these things than the ash does. The ash is always depleted in these compared to the coal. Very small. Let's see if we can find, yeah, look at mercury here. Mercury on this scale doesn't even register. It's not even there for either the coal or the ash. And yet, you burn that coal and you produce mercury pollution. It's kind of interesting, I think. Now, Diane, this is the surprise I told you about. We have always been concerned by the fact that apparently, and I have looked very carefully, Diane has looked carefully into whether there are actually standards, health standards for ash, for bottom ash or fly ash, either one. And what you find if you do that is you come up empty. And I have actually called the people in the county, and I've looked in the state records, and I can't find anything that says that they have any limits for these things. But then I got the brilliant idea to look at the EPA. And guess what? The EPA doesn't have it either. But they do have standards for hazardous waste. Duh. So, that's what this is. If you compare, and these are some of the real meanies here. I didn't plot everything, but these are some of the more important things. The column on the left is the EPA standard for hazardous waste. The column on the right is bottom ash.